humidity, absolute humidity. And second, we have the relative humidity. Absolute humidity is the total weight of the moisture, is total weight of moisture contained in per volume of air at different temperature. At definite temperature. But the absolute humidity will change, and the relative humidity is in comparison, that is, it is the water vapor in grams by the total holding capacity, that is the capacity to hold moisture, weight in gram per unit. So in case of a colder area, now we have a cold surface and another we have a warm surface. In case of the cold surface, we have an air mass suppose this is the air parcel we have, and similar we have in the warmer surface. Now that air mass, in case of the cold areas, they have the capacity to hold the water vapor is less capacity to hold water vapor, and the warmer surface areas or the warmer air will have capacity to hold water vapor more. More capacity to hold water vapor. So now let's consider there is capacity to hold, there is 3, and in case of the warmer air we have the 4 holding capacities, but in case of the cold air only the 2 water vapor will present, and in case of the warmer surface area we also have the 2 water vapor present. So the relative humidity of the cold surface will be 2 water vapor out of 3 into 100, capacity to hold that is 3 and the present is 2 into 100, and in case of warm air the capacity to hold is 4, but the actual amount of the presence of water vapor is 2 into 100. So the relative humidity of warmer air is greater than the relative humidity of colder air. So as the temperature decrease in temperature implies increase in relative humidity. So as the temperature increases, the capacity to hold the as the temperature increases, capacity to hold moisture will also increases, and as the temperature decreases, capacity to hold the water to hold the moisture will also decreases. So the temperature is directly proportional to capacity. Is directly proportional to moisture holding capacity. Relative humidity. Now let us consider we have the 4 air parcels. These are the 4 different air parcels we have. So all of them have 4 water holding capacities, and the amount actual the water vapor present is, in case of A, we have 2 water vapors, and in case of B we have the 3 water vapors, and in case of C we have 4 water vapors. So the relative humidity in case of A will be, here the capacity to hold the water vapor is 4 and the present water vapor is 2 out of 4 into 100. In case of B, the capacity to hold is 4 and the present water vapor is 3. And in case of the C parcel, the capacity to hold the water vapor is 4 and the present is also 4. So here we have 50% capacity. In this case we have 75% capacity, and in this case we have the 100% capacity. So the relative humidity in A parcel is the 50%. In case of the B parcel, the relative humidity is 75%, and in case of C parcel, the relative humidity is 100%. That is, this is known as the saturated air. So the air which cannot accommodate new water vapors. So saturated air cannot accommodate new water vapor. So here what we have concluded, that when the water vapor increases, relative humidity is also increases. So the capacity to hold water vapor increases, that is, this means the relative humidity will decrease. And we have seen that the warmer air holds more water vapor and the colder air hold less water vapors. So if the relative humidity is less than 50%, if the relative humidity is less than 50%, then it will be the dry air. And if the relative humidity is greater than 50%, then it will wet air. And if the relative humidity is greater than 90%, then it will moist air. This is the concept of the relative humidity. Now suppose this is the surface, this is the air parcel. As it will move, it will expand. It will start expand. Further it will expand more. As it will move up, it will expand more. So there is an expansion in the air mass, air parcel. Now if we kept the, now suppose this is the warm air parcel, it will rise. Initially it have the capacity to hold the water vapor capacity to hold the water vapor is 4 and there are 2 water vapors. Now there are 2 water vapors present, that is relative humidity is 50%. And now consider the temperature at the surface is the 40 degree. As it will move up, the air parcel having the temperature 40 degree. So now this whole air parcel will have the 40 degree temperature. This whole have the 40 degree temperature. And that particular air mass temperature will be reduced in that particular air mass having that occupied area. Let's suppose it will reduce to 10%. And similarly the water holding capacity will also reduces. So it will have, instead of 4, now it will have 3 water holding capacity, and out of which 2 water vapor are present. 2 water vapors are present. Further it will move upward, the same air parcel having the same area. Now it will have 2 water vapor holding capacity, and temperature will also further reduce. Now it will have 3 degree temperature, and the water holding capacity still to have 2 water holding capacity. As it will rise up, temperature will decrease for that air parcel. Now it will have -3 degree temperature, and it will have 1 water holding capacity. And as it will move further, so that water vapor will convert into the ice. it will form the ice crystal. And here it will, water vapor will turn into the water drop. And the water vapor will convert into the water drop. That is, this process is known as condensation. That is the level of condensation, that is cloud will form. Now at that point, temperature is reduced and the water will be saturated. Here we have the saturation. That is the 100% capacity to hold the water vapor. So this is the dew point. Temperature of air parcel. This is the condensation will takes place here. Water vapor will turn into the water drop and here it will form the ice crystals. So after the saturation, condensation start is known as the level of condensation. This is the formation of the ice crystals, level of the condensation, dew point, and at the level of the condensation, clouds will form. Now this is in the case of the warm air parcel. In case of summers and in case of winters, we have different type of the air masses. This is surface, air parcels we have. Initially it have capacity to hold the water vapor for, and in case of the cold, and this is warm surface. Cold air masses have the less capacity to hold the water vapor. So let's its maximum capacity to hold the water vapor will be 3, and out of them, in the warm surface area 2 water vapors are present, and in the colder surface area, out of 3, 2 water vapors will present. So relative humidity here is the 50% and here we have the 66%. And as it will rise, as we will move, the water holding capacity of the water vapor will get reduced further reduced and further reduced. So now it will have 2 water vapors out of 3. As it will rise, there will be the 1 water vapor holding capacity. Then it will form, condensation will take place, that is large droplet will form. That is having the high condensation level, and it will further will form, as it will rise, it will form ice crystals. It will form ice crystals. And in case of the cold surface areas, we have the cold air masses having the less capacity to hold the water vapor, that is less than the warm air parcel. As it will move up, water holding capacity will reduces. It will occupy both the water vapors as it will move. So it will form the droplet here. Small droplet will be formed. That is low level of condensation. And here large droplet will form, having the more capacity to hold the water. So it is the high level of condensation. And as it will move up, it will form the ice crystal. So this is the formation of the ice crystal in the warm surface areas and the cold surface areas in the winters and the summers. So both these are associated with the temperatures beyond which the cloud will form, a variable height of the level of the condensation in case of the warm surfaces and the cold surfaces. Over the ocean body, they are closer to the surface with respect to the continents and close to the surface during the winters. So in case of the winters, it will more close to the surface. So the level of the condensation is close to the surface. So the closeness is equal to the crystallization, and now they will form the clouds. So clouds will form at the above level of the condensation form, that is the after the saturation. It will associate with the rising air. So the ice crystals in the water droplet present in the air parcel is known as the clouds. When the warm and the dry air rises, it will condense to form the clouds, and the moist air and the ultimately lead to the formation of the clouds. So there we have the different type of the clouds will also form. Clouds. So we can define them from varying from the heights and the formation of the clouds and the shape of the cloud also. So the clouds having the ice crystals, the clouds which have the ice crystal are cirrus clouds, and the clouds having the water droplets are the nimbus cloud. According to the height, we can differentiate in them. This is our surface. So in the lower height, then we have in the middle, and then we have high. In the low, we have different type of the clouds. In the middle, we have the alto clouds, and in high we have cirro cloud. So these clouds are known as the cumulonimbus clouds. In the lower we have the cumulus cloud. We have stratus cloud. And we have stratus cloud, that is like layer cloud. That is stratus cloud. And we also have the nimbostratus clouds. That is nimbostratus cloud. And in case of the middle, we have altocumulus and the altostratus, having the small clouds. It is known as the altocumulus, and having the cloud are known as the altostratus. Altostratus. And in case of the higher areas, we have zero clouds. These are zero cumulus cloud, and clouds having the structures, these are known as the cirrostratus cloud. And the last we have the cirrus cloud. These are known as the cirrus cloud. So these are the different forms of the clouds we have. So if there is a vertical clouds, will have more rainfall. And short duration. So these are the cumulus cloud. And if they have the horizontal cloud, these are the stratus cloud. And long duration. And we'll have mild rainfall. So these are the features. Vertical clouds, since they will have the more load over them, more water vapors, so they will have quick rainfalls, that is the more rainfall, and it will be for the short duration. And in case of the horizontal clouds, since they are scattered over the large areas, and they can have the long duration rainfall, having the mild rainfall, because of there is not much load, but the water vapor present will precipitate slowly. So these are the different type of the clouds we have. in the higher areas we have cirrus clouds, we have cumulonimbus cloud, cumulostratus clouds, and in the middle areas we have the altocumulus cloud and altostratus clouds. In the lower areas we have the cumulonimbus clouds, stratus cloud, statocumulus clouds, and the cumulus clouds. And vertical clouds, we have two types of the cumulus clouds, and we have the nimbostratus clouds. So these are the two different vertical clouds we have. This is the surface, air will rise, it will form clouds. This is known as the convectional rainfall. So convection rainfall, as the cloud formation is associated with the convective rise of the hot and the humid air, this rainfall is known as the convection rainfall. So overheating of the surface with the sunshine and the localized source of the moisture in the terms of the water bodies and the forest. So the rainfall is considered with the equatorial area where it is everybody phenomena of 4 o'clock rainfall. So because of unequal heating of the different surfaces of the areas, air parcel near to the ground may be warmed up by the condensation more than the air around it. So as the warm air is less dense, it will rise to the upper strata of the atmosphere. When the temperature of the warm and the humid and the decreases below to the dew point, the condensation will take place and the cloud will form. These clouds cause thunder and the heavy rainfall. This type of the rainfall is known as the convection rainfall. It is common on the equator region and in the interior part of the continents, mainly in the northern hemisphere. Now the second rainfall. In India, the convection rainfall is most common in the month of the summer, and this type of the rainfall is known as the pre-monsoon showers. Now let us consider, this is a mountain. Wind is blowing from this direction. So this is the windward side, and this will be the leeward side. Now when these air masses will rise, it will form the clouds. And let's look, this is an example of the Western Ghat in India. So these clouds will collide with the mountains, and after the collision, all of the amount of the rainfall they have will precipitate here. All of the water droplets will precipitate here. So it descend along the. So when the clouds will collide with the top of the mountains, so this cloud cause the wind spread rain on the windward slope of the mountain ranges, and this is the orographic rainfall. And when this air across the mountain ranges, it descend. Now it will have precipitation here. Precipitation will be here on the windward side. When these airs will start moving, so it will descend along the leeward side. So they will start descending here now, and after descending they will get warm and cause little rain on the leeward side. So there on the leeward side we have the little rainfall. Here we have, and in case of the windward side, air will ascend and expanding and clouds. So here we have the rainfall. and in case of the leeward side we have the less rainfall. So the region on the leeward side that receives less rainfall is known as the rain shadow area. So this is the leeward side is known as the rain shadow area. Orographic rainfall occurs in the Cherrapunji in the southern margin of the Khasi Hills in Meghalaya is an example of this orographic rainfall. So it occurs on the windward side of the mountains. It requires inflow of the onshore wind and the highland, that is the mountains, plateaus or the hills. So now this is the mountain. This will the direction of the wind will start rise, will form the clouds, will precipitate here, and in these areas we have deserts. Since it is a rain-shade area or the low rainfall areas, so a desert will form here. So at the highlands located on the coast and across the shore winds, and on the shore winds is the force to rise on the windward side due to the orographic effect. It is the most common mode of the rainfall in the world as well as in India. Southwest monsoon winds and the northeastern monsoon winds both generate orographic rainfall in Indian subcontinent. So this is the mechanism of the orographic rainfall. The next we have the frontal rainfall or the